Cool. Well, first of all, thank you guys for coming along. Bit of context who I am. David Lloyd, I'm a systems engineer for EMC. So work within the pre-sales as well as do a lot of work with customers, proof of concepts, do a lot of work within labs, working with our product teams, etc. So as a consequence of that, get a great exposure to a lot of our technologies. Not only what's on the truck today, but what's coming in the future. One thing that we are seeing at the moment is really another shift in the approach to IT services. And I'm an old guy. I've been around for a few years. I started life actually as a developer, and my first platform that I wrote in. So I've always been pretty well PC based, but it was CPM was the first operating system that I worked with. So probably young fellas probably don't even know what that is. Theos as well was another operating system. PC-DOS, MS-DOS was where it shifted off to after that. Used to write code in WordStar. I don't know if people remember that, but it was a Word editor. Not a lot of debugging going on within the actual IDE itself. You used to get dot matrix printers to print everything out. So the one thing that's been great about the journey that I've been on with that, and I stopped being a developer in the context of that was my sole focus within a few years, and switched over to infrastructure and started still having that sort of development sort of edge. So focused very much on automation, service delivery. So consequence of that, we think of the way that I saw things go, and I worked for banks for 16 years or so. Is like get back here. We're back again. So I saw things such as like a remote boot workstation. I don't know if anyone ever remembers the diskless workstations, RPL, up the end. So fantastic. That was really the first sort of mass deployment of and standardised environments that you could do at scale and do simplicity. In those days, it was quite easy because you just edited a few ini files on the fly as a user logged in. So there wasn't a whole lot. It's quite interesting now that seem to have done a full circle on that, because now when you're editing stuff, you're editing a few text files to make stuff happen. It's just that I don't call them ini files anymore. They call them YAML or something else. So then evolution moved on, so RPL went away, the remote program login, so we went into SOE, COE style context, we're doing automated service delivery, moving on, and then we've sort of went into sort of application hosting and stuff. So there's always been these ways to sort of standardise your environment, get it out at scale, leveraging the tools that are available to you now, sort of getting those response times back and the control. Ooh, your laptop leapt out at me. Through to you. More recently, VDI, if you think about it from a platform service, the year of VDI was 2000. Was it this year? Yeah, I knew it was coming. I've been waiting. So, but what we've seen in the last few years is really, containers. So Docker has started to become a prevalent discussion out there, and we're really starting to see that mature into a sort of production-ready, capable service that can really meet those workload requirements, as long as your application is architected correctly, that you expect from this clicker doesn't work, so that's a bit pointless. So, and what I mean by applications, we think about applications. We've had a few shifts in applications. We've gone from 8-bit, 16-bit, 32-bit GUI. GUI-based evolution into web-based client-server coming in, but now you really got a new architecture starting to come in. There's this sort of, and you hear about it, the cloud-native applications, the 12-factor, the rule book of how you develop those apps ready to be cloud-ready around that. And that, as a consequence of that, these applications are built for sort of mass scale, so they can go out there. They tend to be stateless, although they're still going to talk to a stateful back end to get their data context if the use case requires that. but can go out and scale, and if they fall over, it doesn't really matter because they'll be able to sort themselves out. The balancing, load balancing services, etc. The cross intercommunication will look after the service. It will carry on, and that's the containers. So I've got it. So what the interesting thing? So curiously, how many people are using Docker here or using some sort of containerization? What's your footprint like in your organisation?
In terms of how many?
I'm just using. Yeah, what are you using? So are you seeing a shift in what your traditional infrastructure sort of play over to?
Yeah, so we run in like an Apsera instance of the Apsera platform. So it's not Docker per se, but it's like a runtime. It's a container runtime.
It's definitely and we'll see that the weight shift as applications, and it is as other applications age out, then these new architectures it will be reflected. So we'll see this happen a lot, and it's and why not? It's agile instead of very easy, very quick way to push them out, very nice and easy to standardise and scale it out. And it's portable. Those workloads can run anywhere. In fact, within that. But there's one challenge that comes with containers is there's things that you think, okay, when I start to span across, what about data persistence? What about networking, ability to interconnect? What about some of the capabilities that we're used to in a virtualized world? Being able to prioritise workloads, be able to give resource allocations to that, be able to isolate, control, the micro-segmentation. Sort of capabilities that we have, such as with NSX at the moment. The other side is what are we doing about from a clustering perspective? How do we start to manage those services, but at scale? How do we sort of let them interrelate? We think about that from a VMware perspective. We've got clustering, and this has sort of happened as part of that evolution. We saw workloads shift where applications all of a sudden went from silo perspective to all of a sudden virtualization underpinning them with a high available platform. As a consequence, people will start to write around that. We've sort of gone back to the other area now, but you still need the ability to scale out, meet those requirements, and also cross-communicate. And that's where those scheduling services fit in. And we see many flavours around that. See, Mesos, of course, Kubernetes, Swarm with Docker with since 1.9 as well. Yeah, does it? But at the end of the day, so containers are going to come. That shift is unavoidable now. The conversations we're having, and there's a cultural change that goes with that, as well as and we see that with the customers that we engage. There's also but there's also the way the platform. How do you host this? How do you control that? How do you get these workloads that are ready, that your developers are writing? How do you get them so they're production capable, ready to be hosted at? So you bring all those controls in. I've had conversations with financial organisations. They say, well, we've got it's all good. They've gone out into the cloud. They're doing the development in there out there. Now they need to bring that into a production service, and bring those realms and controls in place. Whether it be compliance and etc. So where can we play in that? Well, how do we, as VMware guys, and I assume everyone here is a VMware guy because it is the VMware user group within that. What can we do to host that, or to provide this sort of a shift? We've already done it with the shift away from standard platforms into virtualization. Virtualization starting with a consolidation style play, data center consolidation, workload agility, meet and test dev, and that evolved into production. We've seen that now with the container capabilities as well, that evolution to be ready to meet all those production needs. So from a VMware perspective, there's three levels that they come from. And there was the first announcement was Photon OS really was the first sort of global announcement. So it's little tiny Linux kernel, small footprint. I think it's 24 meg. Is that right? 24 meg and VMware aware. So effectively that provided a Docker runtime, but in a VMware-centric way. So nice and happy. But the difference is we think about containers. Containers is about slicing its old school style, and I don't mean old school, but the old school where you've got multiple processes running within a box, but with, there are isolation controls obviously there, but you're still, subjected to the scheduling capabilities inside that host, and then you go to a northbound scheduling services when you go into clustering. Think about that, go into VMware, and you think, well, we've got, talk about the challenges of persistence, talk about the challenges of networking. If you start to treat containers as a virtual machine, all of a sudden you can leverage the existing capabilities that exist within your hypervisor, but apply those to your containers. And that's what Photon OS is about. All of a sudden turn your container into, instead of being a single process, turn it into a virtual machine. And then because it becomes a virtual machine, that becomes independently manageable in the same sort of context, so you can apply those services that we have in a virtualization world, whether that be virtual network, NSX, maybe the data management, the storage management within that. VMware have sort of three sort of services around that. The app, has anyone played with App Catalyst here? So, curiosity. So App Catalyst is like a sort of stripped down version of VMware Workstation that's focused. Is that a fair statement?
Yes.
Yes. Thank you, Roman, for your input. But App Catalyst gives you a platform from which you can build out and test your containers based on your desktop, or your laptop, all that. Vic is vSphere integrated containers. So it was Project Bonneville when it was in a project form. So it got a lot of press last year, Project Bonneville, and then has been branded as vSphere integrated containers. What is that? That's bringing sort of container-based capabilities, but bringing that onto your existing assets. So in VMware vSphere, you think, well, I'm used to doing I've got a virtual platform that I've already built out and scaled out, and I've got all these operational controls around that to make it ready for service and integrated into our services within our organisation. vSphere integrated containers is about taking that Photon OS, so the concept of a container-based runtime, and enabling that into your existing vSphere environment. Very easy, but the problem that you may ask around that is you think about containers, and again, you can have that single execution style workloads if they've written their apps aligned to the 12-factor. So what I mean by that is the container gets, they execute a process, it creates a container on the fly, runs that process, and then the container shuts itself down at the end. So no persistence, throws itself away. So it only becomes a single instance style execution. Does that scale when you think about that from a virtual machine perspective, and when we think about vCenter and the limits of vCenter, and we think about the limits of ESXi? Also, today you've got a logical capability of 10,000 VMs, but if you're starting to go mass scale and you've already got a fair footprint in there for virtual machines, and all of a sudden you've got containers as a VM going and at large volume, starting to go up and down, you're maybe putting excessive loads, limits, and putting maybe going to hit constraints within your virtualization environment. So then you've got to look at, well, what's the alternative? Where do you go from there? So you've got you're a brownfield situation, you're a VMware customer, you've gone in with vSphere integrated containers, but now the adoption of containers has extended somewhat, but then you think, maybe I don't need some of those capabilities that are native to VMware, DRS, HA, a good example, because the availability capability should be within the workload itself, not necessarily underpinned by the infrastructure. And that's where Photon has come in. So if you think about Photon OS, what I'm referring to here is Photon Platform. Think of App Catalyst. App Catalyst, stripped down, built for purpose version for VMware Workstation. Photon is a stripped down, built for purpose, platform for containers, but stripped down ESXi on that. So you've got the Photon machine, which is a subset of, microvisor. There's a nice term, coined here, Roman.
That was Scott mentioned it this morning.
Did he? Microvisor? Okay, so a microvisor. And then you have the Photon controller sitting over top, so where you have vCenter within your vSphere environment, you have Photon controller bringing that sort of that capability in play. But it's still ESX underneath the covers. And what do we know about ESX? So we know that the scheduling is significant. It is industry-leading scheduling capability. So, and it's done that, evolved that through mass scale when it knows that it's multiple workloads sitting on a single host, and the prioritization, CPU scheduling, and memory allocation controls are in there. So that's what you want to look at. So if I can apply those advantages into my container-based workload, but strip down some of those constraints and take the limits off that are inherent in a vSphere because of all the advanced services that are within that, and go laser focus into containers. That's what Photon is about. It's about meeting those future sort of workloads, start moving away from the socializing of your sort of, well, whether you call it mode 1 or whether you call it platform 2 or traditional style workloads within your new sort of more cloud native based workloads. Have the two alongside instead of socialise into a common platform. So we cover that. So a quick look at this. Is that running? I was going to do this live, but obviously I can't because it's not even my laptop. So Vic works as a web client plugin. So this is vSphere integrated containers, nice and easy. A virtual appliance installs into vSphere, registers itself into the web client, and from there you can then create these things called the vSphere container host. The container host becomes sort of like what you think about as your control point within there. So your Docker engine. Within that, well, not even that, resource pool, resource scheduler, controller within that. It then creates, you can deploy that, you allocate the resource, that's default to the containers, you deploy that, it then deploys that host, and then within the cluster that you've aimed at, it will then create another template in each of the hosts. So each host gets a hot template. The reason it gets the hot template is that's what spawns these Photon OS container workloads off. It uses, well, VM forking as it is today. So you see these four templates go up, or four, because I'm thinking of my lab environment, but one-to-one on a host perspective come up, and then when you're doing standard Docker-based commands, it will then, it will, I really was trying to get at. It will then spawn, instead of spawning individual containers, it's spawning actual virtual machines. And doing those, and almost because it's using forking, it's instant. So we see it in the lab, it's about a 2-second lag for each container that's being created. Very cool and very quick and very easy because you still control that. So you push it out via the web client. After that, all control is centric to Docker itself or your northbound services. Is that not actually going? Here we go. Now it is. So, and just to re-emphasize it again, another demo, if we look at that, we saw the deployment before. Sorry, I've gone around here. So now when you look at it, when a host has been finished deployment, it gives you, like you expect with a Docker, what we call with Docker, you need your Docker host environment variable that then you post into your client so then it can interact to that client. Again, you've got that Docker host because it's in a vSphere environment that the host itself is subjected to the HA availability and mobility. The templates are pegged to the actual hosts themselves. What you're seeing here is very simple. It's running a simple container. Actually, I didn't see whether, is it doing a compose on that? Just straight through. And then containers. So you see when you create a container, it gets this UID sort of response back onto it. So when you look at the virtual machine, so look at it from a vSphere perspective, the virtual machine name corresponds to the actual to the UID that you return the container. So if you think about how you bring the two worlds together from a vSphere integrated containers perspective, where the VMware administrator provides value, is you can push that out, but all of a sudden you've got the identifier for that container, and then you can parallel to that go back into traditional vSphere style approach and start putting things together like like what we see with tagging, with Kubernetes, and with Swarm. you can start using things such as affinity rules and tagging and all that sort of stuff as you do for identification, isolation purposes. But in line with that, that's, you know, past the forking sort of technology or offering as it is today. But very straightforward. How are we? 1 minute? Yeah, so that's it. Photon itself, so are we allowed to?
No.
Okay, and we can't, yeah.
Actually, just a couple of points to mention if you go back. Is that possible to go back to? Just in terms of the ability to actually interrogate the images that you've been deploying in the UI, in the WebSphere client. If you want to mention that, that'd be useful for some.
Yeah, one thing, this is a shame about the live demo and coming into that. So when you do deploy it, so again, it's about supporting into your ecosystem. So you are a vSphere administrator. So what are you looking at when you deploy that? Those virtual machines are forked off. You go into the VIC into the VIC plugin, and you can then see the host. And then within the host, you can see all the containers that are aligned within that. So you get a nice GUI representation. What you'll also see going forward is an extension on that ecosystem, the operational M&O style capabilities that are within vSphere. Those things extended, so plugins, etc., that are in to also leverage this. So all of a sudden you'll get that visibility in, and because again it's looking at a instance level, at a VM level, you get all those reporting, service capabilities, root cause, etc., monitoring services that are within there. But very cool. I don't know when you'll be able to play with this yourselves.
Very shortly.
Very shortly.
Yeah, very shortly.
Very shortly. There you go. You've heard it here first. Very shortly. Put that in your calendar, which is just straight after very soon. You have, and to be honest, I've been working on it myself for 3 months, I think, now within the lab, and we watch it, and it is a very quickly evolving solution. The Photon itself as well. Think about that. So some other cool things to think about from an EMC perspective. What we're doing to align to this is looking at how do we extend our services and our solutions to align to this new operational model. So we're seeing a converged infrastructure plays that will align to Photon going forward. So you'll have these DevOps appliances, Photon ready, with also a scheduling capability and everything built in over the top, a sort of a PaaS capability built in over the top. So a wheel-in sort of DevOps appliance. We're also seeing the things such as you may have heard of our enterprise hybrid cloud. So a cloud operational solution, customer solution, built around a vRealize suite and EMC technologies. But there'll be a logical extension in that to start supporting the self-service capabilities built around vSphere integrated containers. So what you have is two sort of different approaches. You've got one where we're socializing into your vSphere environment and doing it as a converged infrastructure play. So sort of a bimodal style appliance to quote IDG on the, I think IDG, is it bimodal? Gartner. One of them's platform 1, 2, 3, the other's bimodal. The other side is you'll have a DevOps ready appliance. The other side that we have is look at on the side from an EMC code. There's a lot of activity then working on the persistence challenges that come with that. How do we start bridging the gap between the applications in the containers and and bringing that persistence layer in to those volatile container workloads that sit over the top. So we demoed RexRay earlier between that, and if you think of things such as Cassandra-based databases, those scale-out style architectures, even a MongoDB and MySQL, there's the more single instance, that allows you to bring a common data plane into your containers and start to look at data services, or your data fabric as it is, to become a containerized workload, whereas historically or traditionally, it was almost external to the container-based side. So a lot of rapidly evolving. You're seeing a lot of stuff going in here. You're seeing native integrations, even through Docker Machine, where you can start defining resource controls and all that natively within the Docker client. Very cool. Nice and shifting, great technology actually to play with. Bit of fun. Sleep deprived as a consequence, but really good.